Look up at the night sky. For thousands of years, humans have stared upward, searching for meaning in the stars, feeling both small and connected to something vast. That faint Milky band you see is our home galaxy, the Milky Way, a vast spinning city of stars, dust, and mysteries, stretching across the sky like a cosmic river. Our solar system is just one tiny neighborhood in this immense city, a single address among hundreds of billions of stars. For all of human history, we've been bound to this galaxy, our cosmic island in a sea of darkness. But we are explorers at heart. We've climbed mountains, crossed oceans, and pushed into the unknown, always seeking new horizons. We even left our planet and walked on the moon, turning dreams into reality. Now we ask, can we ever leave our galaxy? Could we journey beyond the Milky Way's shimmering edge? The Milky Way is so immense that crossing its borders seems like fantasy. It challenges our technology, our biology, and the limits of our imagination. Even our concept of time is stretched by the distances involved. Journeys could take millions of years with today's technology. Yet the human spirit refuses to accept limits. We dream, we invent, and we persist. The dream of venturing beyond our galactic shores is the ultimate expression of curiosity and hope for the future. Imagine a future where humanity is no longer confined to a single galaxy, but travels freely among the stars, building new homes in distant realms. This isn't just science fiction. It's a real question for scientists today. How could we ever make such a journey possible? Could the laws of physics allow us to cheat the immense distances of space? Are there hidden shortcuts waiting to be discovered? The dream of leaving the Milky Way is a testament to our ambition and hope, a symbol of our refusal to be limited by the impossible. So, let's explore the true scale of our cosmic home and what it would take to cross its unimaginable distances. We'll see why our current travel methods fall short and why new ideas are needed for such a journey. And we'll dive into the mind-bending possibility of shortcuts through space-time, wormholes that could connect distant corners of the universe. This is the story of Wormholes, a tale of science, imagination, and the relentless drive to go further than ever before. Join us as we embark on this journey, fueled by wonder, to find our place in the universe. To grasp the challenge of interstellar travel, we first need to wrap our minds around the sheer scale of our home galaxy. We must understand the scale of our galaxy, the Milky Way, which is truly mind-boggling in its vastness. The Milky Way is a barred spiral galaxy, stretching about 100,000 light-years from end to end. A distance so immense it's almost impossible to visualize. A light-year is nearly 9.5 trillion kilometers. The distance light, the fastest thing in the universe, travels in a single year. To cross the galaxy, you'd have to travel that distance not just once, but 100,000 times over. It's a journey that dwarfs anything we've ever attempted. Our fastest spacecraft, like the Parker Solar Probe, are still crawling compared to light. Even at their record-breaking speeds, they barely make a dent in these cosmic distances. Voyager 1, after decades in space, would need over 70,000 years just to reach the nearest star beyond our sun, Proxima Centauri. The edge of the galaxy is thousands of times farther than that, a distance so great it's hard to even imagine. With our current technology, it's like trying to cross the entire Pacific Ocean in a tiny rowboat, hopelessly slow and daunting. Even if we could build a ship that travels at 10% the speed of light, a feat far beyond our reach today, it would still take 1,000,000 years to cross the Milky Way. No human could survive such a journey. Entire generations would be born, live, and die aboard the ship, never seeing the destination. The mission would become less a voyage and more a civilization adrift in the endless night of space, forging a new way of life among the stars. How do you maintain society, culture, and purpose for thousands of generations in deep space, isolated from Earth and everything familiar? Conventional travel is out of the question. The laws of physics build a nearly unbreakable wall around us, keeping us close to home. To escape the Milky Way, we need more than a faster engine. We need a new way of thinking, a breakthrough that changes everything. About a century ago, Einstein gave us a new set of rules for the universe, hinting at a glimmer of hope that, perhaps, the impossible might one day become possible. The key to intergalactic travel came from Albert Einstein's theory of general relativity. He showed that space and time are woven together into a four-dimensional fabric, space-time, which can be bent and warped. Mass and energy bend space-time, creating what we experience as gravity. Imagine space-time as a rubber sheet. A heavy object creates a dip, and smaller objects roll toward it. Gravity isn't a force pulling us, it's the shape of space-time itself. This idea was revolutionary. It meant space is a physical thing that can be manipulated. Could we bend space-time in extreme ways? Fold it? Punch a hole through it? Einstein's equations predicted black holes, places where space-time is bent infinitely. Hidden in those equations was another possibility, a tunnel connecting two distant points in space-time. This became known as a wormhole, a theoretical shortcut through the cosmos. So, what exactly is a wormhole, and why does it capture our imagination? Imagine an ant on a sheet of paper, trying to cross from one side to the other. The ant's journey across the paper is like traveling through normal space. Normally, it would crawl across the surface, a long, slow journey that could take ages if the paper is huge, just like crossing the vast distances between stars. But if you fold the paper so the ends touch, the ant can step across instantly, skipping all that distance in between. Suddenly, the impossible seems possible. That's the idea of a wormhole. A tunnel through space-time connecting distant locations, as if the universe itself could be bent or folded. A wormhole has two mouths, connected by a throat, forming a bridge between faraway points. One mouth could be near Earth, the other on the far side of the galaxy, or even in another galaxy entirely, making the universe feel much smaller. Enter the wormhole here, and you emerge almost instantly at the other end, as if you've teleported across unimaginable distances. You'd cross hundreds of thousands of light years in minutes or hours, bypassing the normal speed limits of the universe. It's the ultimate cosmic shortcut, making intergalactic travel practical, at least in theory. Suddenly, distant galaxies could be within reach. Because space and time are linked, wormholes could also connect different moments, raising the possibility of time travel, not just space travel. Some models suggest manipulating a wormhole's mouths could create a bridge to the past or future, opening doors to new timelines. This opens up paradoxes and mind-bending implications, like meeting your past self or changing history. But for now, let's focus on wormholes as a means of travel, our potential escape route from the galaxy, and perhaps one day, a real path to the stars. As amazing as wormholes sound, there's a big catch. A naturally occurring wormhole would be incredibly unstable. It would collapse instantly. The throat would pinch off before even a photon could pass through, let alone a spaceship. So, how do we keep a wormhole open? Enter exotic matter. This isn't just rare matter. It's matter with negative energy density or negative pressure. Normal gravity pulls things together. Exotic matter would push space-time outward, creating a repulsive force. Lining a wormhole's throat with exotic matter could keep it open long enough for travel. The problem? We've never found exotic matter. It exists only in theory. We don't know if it's real, where to find it, or how to create it. Without exotic matter, stable wormholes remain out of reach. Some physicists propose alternatives, like intense magnetic fields, but these are even more speculative. For now, the need for exotic matter is the great wall between us and the stars. Finding or creating it would revolutionize our understanding of reality. It's the key to unlocking intergalactic travel. When we talk about wormholes, we must mention their cosmic cousins, black holes and white holes. Black holes are regions where gravity is so intense that nothing escapes, not even light. The event horizon marks the point of no return. White holes, the theoretical opposites, would only let things out, never in, but we've never observed one. Some theories suggest a black hole could be a wormhole entrance and a white hole the exit, but the intense forces inside a black hole would likely destroy anything entering. Even if you survived, the connection would be unstable and likely pinch off. Using black holes as gateways remains speculative, but these ideas highlight the bizarre possibilities in Einstein's equations. For decades, wormholes were just theory and science fiction. But recently, scientists have taken small steps towards simulating wormholes in the lab. In 2022, physicists created a wormhole-like effect on a quantum computer. Not a real tunnel, but a simulation. They entangled two quantum systems and sent information between them, as if through a tunnel in space-time. In 2015, Spanish scientists built a magnetic wormhole that made a magnetic field appear at another point, as if teleported. These aren't gravitational wormholes, but they show the concept isn't just fantasy. Such experiments are our first baby steps, bringing wormholes from chalkboard equations to experimental physics. They help us test theories about gravity, quantum mechanics, and space-time. While we're light years from building a real wormhole, these analogs are valuable. They reveal the properties a real wormhole might have, and the challenges we'd face. Each experiment brings us closer to understanding the possibilities. The journey is just beginning, the first glimmers of light in a very long tunnel. The quest for cosmic shortcuts is no longer dominated by a few nations. India is rising as a new leader in space exploration. The Indian Space Research Organization, ISRO, has achieved remarkable feats on a modest budget. From its first satellite to missions to the Moon and Mars, India has pushed boundaries. The Chandrayaan-3 mission, landing near the lunar South Pole, was a landmark. This success has inspired a new generation of scientists and dreamers. India's space program is about building a future at the forefront of discovery. As India's capabilities grow, it's poised to play a leading role in humanity's next great chapter, whether on the Moon, Mars, or probing the universe's deepest mysteries. The dream of leaving the Milky Way is a dream for all humanity, and India is helping light the way. As we ponder these incredible ideas, we're left with more questions than answers. Are wormholes real? Do they exist naturally? Or can they only be created by advanced civilizations? We have no evidence yet, only theory. Even if we could create one, would it be safe? Could humans survive the journey? And what about paradoxes? If wormholes allow time travel, what happens to cause and effect? Some scientists believe unknown laws may prevent stable wormholes, protecting the universe from paradoxes. Or perhaps we just haven't discovered the right rules yet. But we must keep asking questions.